morning, everyone. We're going to go ahead and get started. My name is Sean Maurer. I'm a mechanical engineer with the Smart Energy Design Assistance Center. So today is the first part of a two-part webinar series on the COVID-19 and school reopening strategies. Today we're going to be covering prioritizing strategies to reduce virus transmission in your facilities. Today's presentation is brought to you by the Smart Energy Design Assistance Center in partnership with the Illinois Extension Office. CDAC is an applied research program at the University of Illinois, housed at the Urbana-Champaign campus. Our goal is to reduce the energy footprint of Illinois through energy assessments and other programs targeting sustainability, energy efficiency. The Illinois Extension Office links local communities to the university to develop programs, tools, and knowledge that will support needed changes related to health, community, food, environment, and economy. And we thank them for partnering with us for this presentation. Key points that we're going to be covering today. We're going to just briefly overview how COVID-19 is spread and how to reduce that spread. I know this has probably been common knowledge that's covered frequently, but it doesn't help to overview that and just get the key points. We're also going to be identifying universal mitigation measures that have the greatest impact on reducing virus transmission in your facilities. And then we're going to look at some supplemental strategies to ensure clean air delivery within your buildings to further reduce the risk of transmission within facilities. We're conducting a study to assess the outcomes of the COVID-19 training webinars. So we want to know how this information we will share will impact your understanding and application of building safety practices during the COVID-19 pandemic. Participating in this study will include answering a few poll questions during the webinar and completing an anonymous 5-minute online questionnaire at the end of the webinar. You'll be contacted after a couple months to complete a second questionnaire. It's a voluntary study. All the questionnaires will be anonymous, and we've prepared an information sheet that lets you know more about the study, and we've provided a link to that information sheet in the chat box. We're going to go ahead and launch just an initial poll question here as a warm-up, get everyone used to the format and how that poll works. So our first question for you today is just who is attending in person at your school district now? Most or all of your students, half or fewer, or no students? Are you completely remote right now? Give a few minutes for everyone to get their answers in. Okay, it looks like just about everyone's got their answers in, so we'll go ahead and share those results. So it looks like most of you have some kind of hybrid model for your classes. You've got some of your students coming in while some are staying at home, kind of blending the remote learning with in-person learning. But we do have a few schools that appear to be fully open, have all their students back in classes, and a couple, looks like we've got one that is also completely remote still. So thank you. So first thing we want to touch over is just a brief overview of the viral transmission, what we know about transmission of COVID-19, and more specifically, transmission in school facilities. So the long and the short of it is pretty much that we know, based on current knowledge, research studies, that the primary means of transmission is close contact with an infected individual. Long distance aerosol transmission is possible, but it's usually in a specific indoor environmental condition where there are strong airflows or poor ventilation that carries that virus around greater distances. But for the most part, close contact is the primary means of virus transmission. We also know that there are some impacts of the environment on the duration and persistence of that virus in the air. We do know that higher temperature and higher relative humidity reduces the persistence of that virus. For that reason, we have some suggested recommended temperatures and relative humidity levels listed here. The temperatures fall in the ASHRAE comfort guidelines. Straying outside of environmental comfort can add stress to individuals, and that can increase their susceptibility to viral transmission. But the key thing here is being aware of winter humidity control. There's a fine balance there between having too much humidity where you end up with condensation on cold surfaces like windowsills and things like that, and increasing that relative humidity level to the point where you're not drying out people's mucous membranes, to the point where that makes them more susceptible to viral transmission. Um, Also, a higher relative humidity level reduces the amount that aerosols in the air will evaporate and shrink in size to the point where they're easier to be carried on air currents. So the higher relative humidity can help particulates that are potentially carrying that virus to settle out of the air faster. We also know a little bit about how long the virus can live on surfaces. So we covered air. Virus in the air can last up to 3 hours, maybe longer, but most studies are indicating somewhere in that 3-hour range in air. But a lot of surfaces in our classrooms are stainless steel and plastic surfaces. The virus can live on those surfaces for multiple days. So this kind of reinforces the policy of sanitizing surfaces, wiping down frequently touched surfaces to reduce the chance of picking up the virus on your hands and then touching your face, mouth, eyes, anything like that, and possibly transmitting that virus through contact transmission. While studies have not shown that contact transmission is a primary means of transmission, it's hard to distinguish contact transmission from close contact transmission, as usually they're pretty tightly intermingled. So it's important to be aware that that potential risk is there and to take steps to mitigate it. Distance affects virus transmission. This is where the 6-foot rule has been mandated for a lot of facilities and suggested by health organizations. The 6-foot rule is based on that assumption that primary transmission, again, is from larger droplets while in close contact with a person. And if you can step outside that 6-foot radius, those larger droplets are of a greater chance to settle out of the air before they can reach a potentially infectious person and cause transmission. New CDC distancing guidelines have just been released. We were made aware of them over the weekend. In elementary schools, distancing can be reduced to 3 feet apart for students, where mask use is universal, regardless of the community transmission level. In middle schools and high schools, 3-foot distancing, again, is allowable where mask use is universal, but you want community transmission to be on the lower end. You don't want higher community transmission rates. And any unvaccinated staff should remain greater than 6-foot distancing until they are vaccinated. So it's important to be aware of those updates to those recommendations. But again, the primary thing is that distancing allows any particulates that are emitted from a potentially asymptomatic carrier or someone who might be sick to disperse in the air and reduce their concentration level. So the primary things to be aware of to transmit any disease is contact time with the disease and concentration level. If you can reduce the concentration and reduce the contact time, you're going to reduce your overall risk. So getting into the longer range aerosol type transmissions that have been in some studies, again, this is a rarer, a lower risk for transmission, but it does occur. Primary things that impact that are compounding factors like speaking loudly or singing, yelling. People will emit more particulates in those situations. Facilities that have not mandated masking, you're not having source control then. Poorly ventilated buildings, the concentrations of particulates containing the virus can build up over time, and that increases risk. And strong indoor air currents that can pick up those aerosols and distribute them throughout the space. So from ASHRAE guidance, they said there is evidence that the virus can remain suspended and infectious for up to 3 hours, suggesting the possibility of aerosol transmission. However, it's not the primary means of dissemination. Again, the primary means is that close contact that we're avoiding with these universal mitigation measures. So how much should we worry about transmission in schools? The good news that we've seen is that children are less likely to have severe symptoms. However, it does still occur in young children. Less than 10% of the documented cases of transmission are between children and teens. Greater than 90% of those are between adults in indoor situations. Student transmission to adults is rare. There has not yet been a documented case of that, even between children and parents at home, although it's hard to make that distinction in some cases. So it is possible, but it has not yet been documented. Multiple studies indicate that children are not a major driver of infection spread, but again, we've had schools shut down and children have been isolated at home, and that may be part of the reason why that is a lower driver. And now as we're reopening schools, it's important to be aware that we're kind of changing this dynamic. But available data does show that opening schools and allowing students to return is not linked to increases in community spread. It's more likely to be the other way around. Higher rates of transmission into the community are going to result in higher rates of transmission in the school. But reopening the school has not been shown yet in cases where schools are following mitigation measures to increase transmission within the community. But transmission in schools can happen, and that's why we're overviewing implementation measures. Transmission is more likely to occur in schools that do not implement or follow mitigation measures. Face masking and social distancing are very important for reducing that risk. It's also important to be aware that some children do have long-lasting COVID effects. There have been multiple reports of students that have lost out on sporting events and things because they've been impacted by COVID and are no longer able to breathe the same way or have other long-lasting effects from having had to deal with the disease. Community mitigation measures are essential to reduce transmission among teachers, staff, and students. In cases where school studies have found transmission in buildings, it has mostly been tied to events outside the school, social events in people's homes or other facilities that has then been brought back into the school building and resulted in some minor transmission rates in the school as well. And we have seen studies for schools that have not implemented mitigation measures early on in the pandemic that did have severe outbreaks. One of the primary studies came out of Israel. They had schools opened, but it was hot, so they were inside. They were in an enclosed space. They didn't have a lot of outside air. The schools were overcrowded. There were no mask mandates, and they did have severe outbreaks in those schools because those mitigation measures were not followed. So just to overview those key points again, the risk is a function of viral concentration and contact time. If you can minimize those, you minimize your risk. Close contact with an infected individual is the main transmission path. So maintaining greater than 6 foot distancing is going to reduce that transmission rate to a rare but possible situation. Student transmission to adults is again rare but possible. Schools have not been shown to be the drivers of community outbreaks. It is more tied the other way around. Outbreaks in the community are linked back to transmission in the schools. However, schools that don't follow mitigation measures have seen outbreaks, and that's a key point to remember. You don't want to get lax on these measures over time. Keeping the mask mandates and distancing practices in place is going to help ensure that your school does not become an outbreak location for the disease. So before we move on to the next section, we have another poll question to test your existing knowledge on mitigation measures for buildings and universal mitigation measures. So I did want to launch that poll now. Our first question, do you know what the minimum efficiency rating value for your filter should be to capture virus particles? MERV 7, MERV 8, MERV 11, or MERV 13? And then what's the recommended CO2 level to reduce risk of virus transmission while avoiding higher energy costs? If you don't know, go ahead and just take a stab at those and guess, and we'll cover these in the presentation. But we do want to see where your existing knowledge level is. And our last question is, which of the following is the best option for ensuring clean air delivery? MERV 8 filtration of recirculated air, in-room purifiers, located under a return vent, a window fan exhausting to the outdoors, or a window fan blowing into the room. So we'll give a few minutes for everyone to put in their responses there. Okay, looks like most people have got their responses in, so we'll go ahead and share those results. So it looks like most people believe the MERV 13 is the minimum filter rating for cleaning the air. We'll touch on this later, but that is the correct answer. Recommended CO2 level to reduce risk of virus transmission, 800 parts per million was the most popular answer there. Again, we'll touch on that later in our presentation. And then the best method for ensuring clean air delivery, window fan exhausting to outside was the most popular answer there, although this one was a little more split. So we'll touch on this in detail, make sure we focus on this particular issue because it is important to know. Okay, so let's touch on universal mitigation measures. Again, this section is covering masking, distancing practices. Most people are well aware of these, so we're going to zip through them fairly quickly. If you do have questions, do please post those into the Q&A window, and we'll address them towards the end of the presentation. But these measures have the greatest impact on risk mitigation in your facilities. If you do not employ these universal measures, the changes that you make to your building equipment and facilities as far as increasing ventilation or adding supplemental air purifiers, things like that, are not going to have nearly as great an impact. Diligent face masking is source control of the virus. If someone does happen to be an asymptomatic carrier, wearing that mask helps to trap those particles without releasing them into the space where they can be distributed. Social distancing provides that distance between individuals for anyone who may be infectious to then dilute viral particulates. That reduces that contact concentration and also allows for fresh air and exhaust systems to draw those particulates out of the air before they can contact somebody else. So you're getting a little more time there for dilution and for exhaust of potentially virus-laden particulates. Hand washing and surface cleaning is going to reduce your risk of contact transmission from surfaces. Forming student cohorts, groups that stick together throughout the day, allows for easier contact tracing. If someone is identified as being infectious and potentially transmitting the virus, you can isolate that particular group, let those students be in quarantine for a week or two until they have displayed that they either have no symptoms or that they've passed the virus and then can return back to the building. It just limits the size of the potential outbreak group. It also makes tracing contact between individuals easier and encouraging people to stay home when they are sick. So just touching on face masks briefly here, it's very important that those face masks are properly fitted to cover the nose down to under the chin. You don't want people wearing them incorrectly, otherwise they're not providing that source control that is effective for mitigating virus transmission. Studies have also shown that multiple layers are better. A lot of masks now are already pre-built with multiple layers, but if someone's bringing a homemade mask or something like that, important to let them know that multiple layers do help with better filtration of the air and capturing any particulates they may be emitting. And we do have a link when these slides are provided to you after this presentation to the CDC's mask recommendations, gives you a little more detail on those. Probably the biggest thing you want to be aware of is there are some masks out there that have, as you can see in the top center picture here, these vent valves in them, makes them easier to breathe through. But those leave an opening in the mask for transmission. So very important to have a mask that's properly fitted, has at least a couple of layers to it to improve its capture efficiency. Some social distancing reduces your local concentration. Building measures such as setting up signage to direct traffic in hallways, setting up single flow entryways to classrooms, having an entrance door and an exit door if a room happens to have multiple entrances, setting up one-way stairwells for multi-story buildings. These are ways to reduce mixing in the hallways as people are transitioning between classes, if that is a policy you still have in place. But essentially setting up ways to maintain that social distancing even in transition periods. Installing physical barriers where distancing can't be maintained. Places like reception desks. I know some teachers' desks, places in classrooms where you cannot maintain distancing, setting up barriers between desks can help reduce the potential for transmission. Although setting up those barriers does also change airflow patterns, it's important to be aware of that, and we'll touch on that later in the presentation. Adjusting your classroom layouts to promote distancing. A lot of times classrooms have desks kind of clumped in the center of the room, spreading them out as much as possible to maintain that distancing. Closing and repurposing communal spaces such as cafeterias, libraries, auditoriums. These areas can be repurposed to expand instructional space to allow for greater distancing for classrooms, reducing that population density to reduce transmission risk. Forming cohorts, again, makes contact tracing easier, and if you do happen to have an outbreak, it limits the size of that outbreak to just that small cohort group. So forming cohorts of students that stay together throughout the day. Some schools have taken up a policy where students stay in a classroom in a group and the teachers rotate around. It's a little more difficult for high school type formats where typically students have different class schedules where they then intermix. But finding ways, if possible, to maintain those groups is a great way to reduce risk in facilities. Staggering class schedules to reduce mixing in the hallways is another strategy. You want to release one classroom group maybe 15 minutes ahead of another, gives them a chance to get through the hallways, get to their location, then release another group so that the hallways themselves don't become overcrowded and you increase transmission risk potential in that situation. Another thing to be aware of is limiting non-essential visits. Bringing in people from the community into the building. Again, you're increasing that potential to bring in an asymptomatic carrier. And so limiting that to only essential visits is a good way to reduce potential transmission risk. Hand washing and surface cleaning reduces that contact transmission risk. The virus can live on surfaces for multiple days. So it's important to practice regular hand washing, as if someone does happen to touch an infected surface, that's the best way to remove that virus from their hands. Hand sanitizers are not as preferable as hand washing, as the sanitizer doesn't actually remove the virus from your hands, it kills it on your hands. But it is not 100% effective at that kill rate. So if hand washing isn't available, sanitizer is a good backup, but regular hand washing with soap and water is the best way to remove those particulates from your hands. Cleaning frequently touched surfaces at least daily, door handles, light switches, surfaces that are in regular contact with multiple people should be cleaned as frequently as possible, at a bare minimum at least daily. We have seen some schools set up a policy where they're doing that between classes. And then discouraging the use of shared items, having students bring everything they need to the classroom, pencils, scissors, all that kind of stuff, just reduces that potential again that somebody is ill, puts that virus on an item, passes it along to someone else. So if you can follow those measures, those are going to be the bulk of your risk reduction. 80–90% of your risk reduction comes from those key measures: masking, maintaining that distancing, and cleaning, sanitizing services, and hand washing. But what we're going to get into next are ways to increase your risk mitigation through changes to your building's facilities. And this is probably where people need the most help. So assessing space risk to determine where additional measures are necessary or desired. Increasing your outside air ventilation rate, which has been a recommendation from most health organizations since the beginning of this pandemic. Monitoring CO2 levels is a good way to verify the ventilation rates in your facilities, and we'll touch on how to do that. And then cleaning the air through filtration and purification systems, especially if there's a high community spread around your facilities, or if you have limited ventilation options for bringing in more outside air. So this is just a table of risk factors to go review for your facilities, different locations and rooms. You're going to have higher risk in rooms that have a higher occupant density, number of people per square foot. Students that are transferring between classes, where you've got mixing of groups, is going to increase risk. Where your duration, if you've got visitors coming into the building, teachers working with students where you've got that close contact for greater than 15 minutes is going to increase your risk. Adequate spacing, you want to maintain that 6-foot distancing between occupants, and the new guidelines are allowing for 3-foot distancing between younger students. Um, for ventilation systems, if you don't have proper ventilation, a good way to bring in regular controlled outside airflow, or your ventilation system is not working properly, is going to increase your risk. Where you've got reduced filtration efficiency, most HVAC systems have these MERV 8, MERV 11 filters. Um, they are there mainly to protect the equipment from dust buildup, but not to filter the actual air into the space. Um, and the type of activity is something to consider. Where you've got higher activity, higher metabolic rates, you increase respiration rates, and that increases, if someone happens to be an asymptomatic carrier, that's going to increase their emission of virus particles. So you're looking for rooms where these higher risk factors are a condition. So like a gymnasium where people are active and moving around doing exercises. Um, most classrooms are going to be kind of a moderate to high risk situation because you've got multiple students in a enclosed space with a teacher, especially if you're back to fully open schools and you've got class sizes that are, somewhere in the 30 student range in that classroom. Is kind of typical. You've got that higher occupant density. You're going to have interactions between those students that all increase risk of transmission a little bit. So what we want to focus on is, first, how do you bring in fresh outdoor air? Because this is going to be the next biggest way to reduce viral load in the space. Bringing in fresh outdoor air helps dilute particulates in that space, and also bringing in that fresh outdoor air pressurizes that space a little bit. Now you've got to exhaust some air out. The air that's exhausted out of that space will take virus directly out of the space as well. So fresh air can be supplied by a central air handling system. Some buildings have unit ventilators or wall-mounted HVAC units for classrooms that are supplying that fresh outside air. Or in some really older buildings, they have radiant heating systems and window units. Your only means of increasing ventilation is through natural ventilation by opening those windows, placing a fan unit in that window to bring in some outside air in addition to what's already there. Um, so these are ways to increase that fresh outdoor level. We do recognize that different buildings have different system types, different complexity levels. So we wanted to touch on how, for each of those different building types, you would be able to control your outdoor air level without overwhelming your HVAC system and creating a condition where it's uncomfortable for people in this space, simply to increase that outdoor air ventilation rate. If you have a central building automation system that has demand control ventilation, where you've got CO2 sensors that control your outdoor air minimum levels, decreasing that CO2 set point from 1200 parts per million to 800 parts per million gives you a good balance between increasing your outdoor airflow rate. It'll increase that outdoor air change rate from about 1 or 2 air changes per hour up to 3 or 4 air changes per hour. But that 800 parts per million setting also prevents the system from being overwhelmed when we get into extreme temperatures, like back in the winter when it was very cold, or as we get into the summer when it's hot and humid. You get a good balance there where the system can still keep up and provide comfort conditions to the space, but you're increasing how much fresh air you're supplying to the students. If your system's a little more simplistic and you don't have DCV CO2 sensors, you just have a fixed minimum outdoor air setting for your systems, check that set point and increase it slightly. It's a bit of manual control you have to do here. It takes active control from day to day as weather conditions change. The main thing you want to be aware of here is that you don't want to overwhelm your HVAC system with outside air to the point where it cannot maintain comfort in the building. So when it's mild out, you may be able to go to nearly full outside air, maybe somewhere in the 70–80% outside air instead of recirculating air in the space. But as we get into more extreme temperature conditions, you may be forced back down to your original minimums that are typically in the 15 to 20% range, so that the system can keep up and maintain comfort conditions in the room. So If you do have a fixed minimum outside air set points for your air handling systems, it's important to be aware that that will need frequent adjustment to maximize the amount of outside air without overwhelming your HVAC systems. If you've got unit ventilators in classrooms or HVAC systems that aren't tied to a central BAS system where it's distributed controls, look at the control systems for those individual units. Typically, it's a pneumatic device that controls the minimum outside air position. Um, See if that can be adjusted, have that set point changed, work with your HVAC contractors to increase that outside air as much as possible. Maybe get trained, have someone in the building trained how to adjust that so it can be adjusted on a seasonal basis maybe to maximize the amount of outside air you can bring in without overwhelming those systems. If you don't have a ventilation system, you're in a building that has radiant heating and window units, does not have forced air systems, use operable windows, open those up to allow outside air to ventilate into the room. Um, Understanding that outside air ventilation is variable. If you're solely relying on wind pressure and temperature from outside to drive air currents through the building, that's going to be highly variable. A good way to provide more consistent ventilation is to place a fan in that window. Um, we do mention that if you do place a fan in a window, you want that fan to blow outside of the building. If you blow air into the room, you're creating a strong air current, and that can potentially spread the virus throughout the space. And we touch on that here. There is a great New York Times article. It had this image on the screen as you scroll through the article. It discussed the airflow patterns that were being shown in the image. And we've got an example here where they placed a fan in the window and blew that fresh air into the room. And while this is supplying additional dilution, you can note here that if the infected individual happens to be sitting right under that fan, it's blowing those infectious particles directly onto other occupants in the space. A better way to do this is to point that fan to the outside. That way you're exhausting any potentially infectious particles out of the space. Um, Outdoor air will then leak in through other openings in the room at a lower velocity. So you still are maintaining the possibility for those particulates to settle out of the airstream, get out of the breathing zone of the occupants. It's a little bit safer than having a strong airstream blowing directly over occupants in the space. Um, Same thing to consider if you've got a portable air cleaner in that space or you're setting up a fan to increase air circulation. Make sure that those strong air streams aren't blowing directly on individuals. Try to have that air directed towards passageways, corridors set up between desks where that airflow can dilute and slow down in the space, and then provide that mixing and dilution that you need to reduce infection risk. So we've talked about increasing that fresh air ventilation rate. How do you know if you've got enough, especially if you're at minimum conditions? A good way to track outdoor air levels and ventilation rates in this space is getting a CO2 sensor um, that, and then sampling spaces and tracking them to ensure that they are receiving adequate ventilation. And you're targeting that 800 parts per million for a space. This equates to about 40 CFM of airflow per person. Most mechanical systems per ASHRAE design standards are designed for about 20 CFM of airflow per person. So you're typically targeting somewhere between 1150 and 1200 parts per million of CO2. It's important when you're taking CO2 readings that you're using a quality CO2 meter. There are some cheap ones that are just desktop models. Their accuracy isn't very accurate, so you can get false readings, either low or high. A good handheld sensor like the couple that we're showing on the screen here costs about $250 to $350. And so it's good to take these into a space, occupied classroom. Make sure when you take the sample that you're taking it away from occupants. You don't want someone who could potentially directly breathe onto this because you're going to get a false high concentration reading. Set it on a desk, countertop, bookshelf that's away from the occupants where the air has been diluted already, and that gives you a good reading of what the average CO2 reading in the space is. And this is, again, just a very good way to go through your facilities and verify that you're getting that adequate fresh air ventilation. And one thing we wanted to note is that this is going to have benefits far beyond COVID-19. There are multiple studies that show that increasing fresh air ventilation into buildings improves um, cognitive function, reduces sick days, um, and so there's a long-lasting benefit to increasing ventilation rates in buildings beyond just trying to mitigate transmission of the virus. Um, and so we did want to touch on that here, that even after the pandemic is over and we're kind of getting back to normal operations, you may want to consider maintaining these increased ventilation rates for your facilities, because they do have these other benefits as far as cognition, student performance, reduced sick days for staff and students, um, that can have much greater benefits beyond just the considerations of energy costs for your facility. So now that you've increased your fresh air ventilation rate as much as possible, the next thing to target is any recirculated air within the space. If you've got portable air cleaners that are doing purification in the space, for air handling systems that are drawing air into a return system, treating that air, and then sending it back into the space, um, you want to make sure that any recirculated air is filtered and sanitized before it's sent back to the space, especially if you're in a high risk community environment, or you have a room that has high transmission risk. This is especially beneficial if you've got limited fresh air ventilation options, particularly if you're in a building that doesn't have mechanical ventilation systems, like the older radiantly heated buildings with window units. Um, this is a good way to increase what's called the clean air delivery rate into a room. And again, if you've got high community spread, you've got that higher risk of potential transmission among students coming into the building, then you may want to also consider these as well. The first thing, probably the easiest thing to do, is to increase your filtration efficiency for your systems. Recirculating air through a MERV 13 at minimum to a MERV 16 filter will give you about 90% filtration of the particulates that carry that virus. Those particulate sizes are expected to be somewhere between 1 micron and 50 microns. And as you can see in the chart here, MERV 13 and 16 filters filter out 90% or better of those particulates. So this is a good way to improve the efficiency of filtration, improve the cleanliness of the air in the space. It is important to be aware that this does have an impact on your fan energy. It will increase the pressure drop that that fan sees, which can either, if the fan is a constant speed fan, it'll reduce the amount of airflow it can produce into the space. If it's a variable speed fan, the fan's going to ramp up in speed. It's going to increase your energy consumption slightly. But it's very important that you do not recirculate uncleaned, unfiltered air in a space, as that can allow concentrations of the virus to build up over time. Another thing to be aware of, even if you've already got MERV 13 filters, is to make sure that you minimize bypasses of these. Check your unit ventilators. The filter's usually on the floor at the bottom of the unit. Check your central air handlers and make sure that there aren't gaps between these filters. Just a 10 millimeter gap can drop the effective MERV rating of your filtration system by half or more. So just some example pictures here. It's a large rooftop unit on the top left, showing an end plate that was missing. That end plate pinches those filters together. This allowed the airflow to actually split the filters apart and left about an inch gap between them. And so these filters were essentially doing nothing to filter the air for this unit. The middle picture there is just a filter gasket on a filter bank. The gasket's fallen out of place. That leaves a gap for air to move around those filters. And the bottom image is just showing some angle plates that are holding the filters in a rack. The seam between those plates need to be sealed with caulking or some other air barrier material to prevent air from moving between those filters where it's not being filtered and cleaned. But as I noted, improving your filtration rate in the building is going to increase the fan energy consumption, or if your fan is a constant speed fan, it's going to reduce the airflow rate that that fan can produce. The additional fan energy that you could expect, we picked just kind of a round number here as an example, about a 10,000 CFM fan. You could expect that fan energy to increase by about a third of a kilowatt. And for a typical school operating schedule, where it's the fans operating intermittently, not running 24/7, it's about $100 a year. If your facilities are running 24/7 to provide ventilation, air cleaning after occupants leave, this goes up to about $150, $175 per year. Um, Ways that you can mitigate how much that fan energy is going to increase. You can select deeper filters, which may require modifying the filter rack for the system. But if you can increase the filter area of that filtration system, that decreases the velocity of air moving over the filter, which then decreases that pressure drop. Um, there are also filtration media available that have electrostatic properties to the filter media. And so the actual density of the fibers might be more similar to a MERV 8 filter, but because it can attract and attach particulates out of the airstream, it acts more like a MERV 13 system. They are more expensive, whereas a MERV 13 filter that doesn't have those electrostatic properties, the pricing can be on par to slightly higher than a MERV 11 filter. Um, it does have that better efficiency, and may be able to fit in a thinner filter without having to increase the size of the filter racks for your system. If your air handling systems cannot handle the upgrade to a MERV 13 filter and you had to drop back to a MERV 8 filter, or you're just got a space that needs some additional air filtration because there's a high density of occupants, there's a simple, innovative solution that a lot of facilities have come up with to have an air purifier in the space for less than $50. Whereas if you go with a professional air cleaning device, those tend to be in the $250 to $350 range. But essentially, you can take a box fan and place a MERV 13 filter on the inlet side of that fan, and now you've got a system that's filtering out 90% of those virus-laden particulate sizes. So again, you can consider this if you don't have access to outside air for a room, you need to increase your risk mitigation levels through another method. If it's too hot or too cold, to increase outdoor air ventilation rates, or if your system was unable to be upgraded to a MERV 8 or a MERV 13 system due to airflow issues. This is a good way, cheap way to then increase that filtration rate within the space itself. Something important to note, you want that filter on the inlet side of the fan so it's drawn sealed against the face of that fan, and that limits filtration bypass. It's also important, again, as we noted earlier with the window units, that you don't want to have these pointed directly at occupants. You want them directed towards aisleways between desks, maybe blowing towards a wall or something where the airflow can then diffuse along the wall, and therefore it reduces that airflow velocity that can carry particulates farther away from individuals. The right side image here from the Yale School of Public Health is actually just a way to increase the clean air delivery rate of this fan system. The image on the right, you're going to have some pressure drop through that filter, which is going to limit how much airflow this fan can develop. If you make a larger box out of those filters, again, you're increasing that filter area, and that allows for a higher volume of air to pass through that fan at a lower pressure drop. And again, it's just increasing the rate of clean air delivery to the space as much as possible. So once you've addressed increasing outdoor air ventilation as much as possible, and you've addressed filtering that air as much as possible, so the last thing that kind of reduces your risk is purifying that airstream. And there are multiple technologies that can do this. You can add ultraviolet germicidal radiation to your air handlers. You can add it to a space with a premium quality air purifier. Adding it to an air handler costs somewhere around 25 to 50 cents per CFM. Electronic air purifiers can either improve filtration or actually kill microbes in the air or deactivate viruses. Adding these systems to an air handler costs around 15 to 20 cents per CFM. Or you can use portable air cleaners in the space that combine HEPA filtration or just high filtration rates with one of these air purification strategies. Again, these units cost anywhere from, at a minimum, about $300 per unit. Higher end products with more technologies in them can get up to about $500, $600 per unit. But again, we want to stress that you don't want to be recirculating uncleaned and unfiltered air within the space. So touching on first the UV germicidal irradiation, um, it's a proven air cleaning technology. It's been used for decades in hospitals and clean room facilities to clean the airstream going into a space. There's two different ways to do this, and your choice may depend on your budget and how much funding you have available. You can do a bit of a reduced UV energy system that focuses mainly on cleaning the cooling coil. It will have some cleaning impact on the airstream itself, but the primary purpose is to prevent the buildup of microbes and biological material on that cooling coil. Since it generates condensation, materials can grow on that. For about a 10,000 CFM air handler, a UV system for cleaning the coil is going to add about a quarter to a third of a kilowatt, and about $80 per year to the operation of that unit. If you're looking for, and you have funding available for more advanced air purification, you can increase the intensity of that UV to get single pass airflow cleaning. It takes 8 to 10 times the UV energy to clean those systems in a single pass of airflow over that UV section of the air handler. So there is a significant energy addition for this type of system. You're looking for a 10,000 CFM air handler, about 1.5 to 2 kilowatts, or about $600 a year, a little bit more than that. Something to be aware of is these UV lamps do need to replace every 12 to 18 months. They will still generate light after that period, but their UV production drops off significantly. So it's important to be aware there is a maintenance component to adding a UV system to your air handlers. Another option is ionizing air cleaners. These use a high energy plasma to split particulates in the air into ions, oxygen atoms, and water vapor. Those ions can be used in two different ways. You can have an electrostatic precipitator where those ions attach to particulates in the air and then flow through charged plates that then attract those ions to the plates and draw particulates out of the airstream. It's a favored system because it has a very low pressure drop, so you don't have the impact on your fan energy consumption like you would with increasing filtration with filter media. The other option is a free ion generator where there is not a charged plate. You're just generating ions into the airstream. Those ions attach to particulates. If that ion generator is before your filters, that filtration system can then attract those particulates and you get improved performance from your filtration system. Those ions can also attach to microbes and inactivate viruses and kill bacteria. And ions that are emitted into the space will improve the settling rate of particulates to surfaces, as those charged ions will then attract those particulates to surfaces. So that's a couple different ways that those ion generators work. We do want to caution you about picking these systems though. A lot of ionizer technologies have the potential to produce ozone, which is a respiratory irritant and can cause problems in your facilities. So if you're looking at an ionizing technology, particularly an in-room air purifier that has ionization technology, you want to carefully consult the manufacturer data to make sure it is UL 2998 certified for zero ozone emissions, or has a UL 867 rating, which is a standard for electrostatic air cleaners that also contains a component for low ozone emission. There have been a number of studies on these. We've read some consumer reports and some other studies on the efficacy of these systems. If you're going with, there are some of these room air purifiers that are advertised as quiet, where they don't have a fan that circulates air through them. They just kind of let natural drafts carry airflow through them. Those don't have a very good clean air delivery rate, as they only clean the air immediately around them. So if you do opt for one of these systems, you want to set up some way to drive air through them. Um, but I would recommend staying away from these low flow, quiet um, air purifiers, as they do have reduced efficiency. Something else to be aware of is the high energy used to produce those ions. Can also break down VOCs in the air, volatile organic compounds, which are emitted by glues in the space, furniture. Most components of the building environment emit some amount of VOC. Even people emit VOCs as far as carbon dioxide, carbon monoxide. Those can react with the ions in the air and create more hazardous particulates, such as formaldehyde, aldehydes, and ultrafine particles, which are harder to filter and can penetrate deeper into the lungs. And those that can be detrimental as far as if there does happen to be viral load in those particulates, it's carried deeper in the lungs, it's going to increase your risk of transmission of the virus. But there's also just the increased risk of respiratory irritation. So it's very important when you're selecting these technologies, look for those 2 UL ratings. Those are going to ensure minimum risk. There is a new technology that's coming out. Instead of using a highly energized plasma, it uses a low voltage to create ions called needlepoint bipolar ionization. Again, our caution is this isn't a rigorously tested technology. It hasn't been through strong academic research study on what kind of air quality it produces. But there are a number of positive case studies. These systems have been used in universities, hospitals. There's a number of schools that are installing them, and all the case studies are noting an improvement in reduced sick days, improved air quality. So this is an option to look into, but again, we caution, it isn't a proven technology yet as far as rigorous research. But it is an option that's out there. It does have a lot of positive case studies and reviews. But it works the same way as other free ion air purifiers. The low voltage energy just creates ions in the airstream. Those attach to particulates and cause them to settle out or filter better with your existing filtration system. And they can inactivate bacteria and viruses in the airstream by attacking the envelope around those units. So to wrap up, our universal mitigation measures have the largest impact on your transmission risk, or the key things to make sure that you're going to reduce transmission risk within your facilities. Without doing masking, distancing, cohorting, hand washing, any building measures that you add to the building are going to have limited impact on your reduction in transmission risk. It's very important to have source control and distancing to allow dilution to happen in order to mitigate risk. But in those cases where you've got higher risk areas, it's important to increase your fresh air, maintain that 800 parts per million CO2, test for it in your facilities, buy a handheld CO2 sensor to ensure that you're getting that proper ventilation rate. If you're not, look into increasing your outdoor air ventilation or reducing sizes, density of occupants in that space. Improve your filtration up to MERV 13 at a minimum. That's going to filter out 90% of those particulates that are expected to carry the virus. Don't recirculate air unless you've filtered it and cleaned it. If you're looking for at supplemental air cleaners for a room like UVGI or ionizing air purifiers, again, look at those with caution, but those are good options for particularly high-risk rooms where you might be limited on filtration strategies or ventilation strategies. And lastly, are the measures worth it? Is all this additional energy consumption for your buildings worth it? They do help reduce virus transmission. Beyond COVID, you've got flu seasons that impact schools throughout the year. Advertising these measures to the community can help reassure parents and staff and students that facilities are safe to return to. They're going to improve the productivity and reduce illness and sick days long after the pandemic is over. They are likely to increase energy costs, but the benefits far outweigh that additional energy consumption. We do have a final poll. We're going to be asking 3 questions again. They are similar to what was asked earlier, but we want to see what you've picked up from the presentation. So again, what's the minimum MERV rating for filtration that's recommended? What's the recommended CO2 level to reduce risk of transmission while avoiding high energy costs? And which air delivery option is best for ensuring clean air delivery? We've had a few questions come into the chat. I'll address those while people are answering this poll real quick. Let's see here. We did have someone ask what schools have or are planning to implement air purifier units in classrooms, and if so, how many air changes are they aiming for per hour, and is there an issue with sound from those units? Is there a make model that is recommended? If anyone in the attendee list has implemented air purifiers and wants to comment on that, raise your hand and I can allow you to speak. We can go at it that way. But I do know some air purifiers, particularly if you're doing an in-room fan unit with a filtration system, will create some additional sound level in the room. There are units that are specified for lower sound decibel ratings that are more applicable to school facilities. But I do want to caution against silent units, ones that are fanless. Again, they don't circulate air through them very well, and so that reduces that clean air delivery rate. As far as the target air changes in a room, the combination of fresh outside air and cleaned recirculated air that's been purified and filtered should target somewhere around 6 air changes per hour at a minimum, is what we've been seeing from health organizations, and that's typically what hospitals have for waiting areas and places like that. So that's a good target for that clean air exchange rate. Looks like most people have answered our poll questions. Let's just review that quickly. MERV 13 is the correct answer. That is the minimum filtration recommendation. Looks like most people got that answer correct. The 800 parts per million CO2 target does ensure adequate ventilation with minimum energy impact. If you're increasing beyond that rate, you're having a drastic increase in your energy costs for fresh air ventilation without a great impact on the quality of the air in the space. And the last question, looks like most people got this. A window fan exhausting to outside is the best way to ensure clean air delivery. Just to comment on these briefly, the MERV 8 filtration, again, isn't filtering air for the space. It's filtering air for the operation of the mechanical system, keep the coils and the fan clean. An in-room air purifier under a return vent, it's going to take that purified air and exhaust it straight out of the space. So it's not going to dilute air in the space effectively. When you're placing an air purifier in a room, you want to make sure it's placed away from return vents and exhaust systems in the room. If you don't have a good sense of the airflow patterns in the space, the common recommendation is to place it in the center of the room so that it can mix effectively with the space. If you do have a good idea of airflow patterns, you want to make sure that air purifier isn't disrupting those patterns. You want it to contribute to them. So you want it to draw in dirty air. So you might want to put it, let's just as an example, airflow goes from over a teacher at the front of the room, passes over students moving towards the back of the room, and exhausts out the back of the room. Ideally, in that situation, you would want your air purifiers kind of in the middle of the student section of that room, so that dirty air is drawn in from the front section of the class, cleaned, purified, and then passes over the back section of the class. That maximizes the amount of clean air those people are going to see. We do want to share some resources. We looked at these resources heavily in preparation for this presentation. Our own webpage has links to a number of these resources, the smartenergy.illinois.edu/COVID-19-resources. The University of Illinois has also developed a COVID-19 toolkit. It's a questionnaire format as you work through a survey of what types of mitigation measures you're planning to use at your school. It has tool tips as you click through the mitigation measures to explain why they're effective. explains why some of them are less effective. So it can help you with decision making. And at the end, after completing that survey, it helps you generate checklists. So you can go through your facility and ensure that your mitigation measures are being properly employed by staff on site. We also have links to the CDC's coronavirus schools page, the Illinois Department of Public Health, and links to the Illinois State Board of Education's recommendations as well. While I'm going through the Q&A here and looking at some of the questions that have come in, we do have a survey, as we mentioned at the start of this presentation. It's about a 5-minute survey, just going over things that you are implementing in your facilities, what your plans are for COVID mitigation. So please, while we're going through the Q&A, take the 5 minutes, go through that survey, and try to get those responses back to us. That's going to help us with our program for understanding the impact of these education materials for schools, and also help us understand what additional information you may need for future presentations. We did have a comment from someone. They had an HVAC system where they tried to increase from MERV 8 to MERV 13, but had issues and had to go back to MERV 8. Their units were shutting down on limit switches, turning off the fans. So for that facility, another good option, as we mentioned, is setting up MERV 13 filters in the rooms, either with an air purifier system or setting up a box fan with the air filtration unit on it. Again, noise is going to be a bit of an issue from having units in the room. You can get units that have limited decibels of sound emissions that are designed for classrooms. You can also kind of control when they're in operation. During lecture periods, you might be able to turn them off when just the teacher is speaking, and then turn them back on during quiet periods of the classroom, study periods, or whatever may be the case. The key thing there again is trying to hit that fresh air exchange rate. You can do it intermittently. That still works for reducing risk. It's not as effective as continuous, but it does work. It is an option. We did have a question on, are there thoughts on having one expensive CO2 sensor for verification of spaces, and then maybe some cheaper desktop sensors for teachers to use? My main thought on that is there are already concerns from staff about ventilation, air quality, air change rates. I know a lot of teachers have expressed concerns about whether schools' mitigation measures are actually effective at reducing the virus. My concern with having cheaper sensors in the space for teachers is that if you do get a false high reading, that could exacerbate issues with security, a sense of security for those teachers. But if you can kind of caution that ahead of time with those teachers, let them know, maybe set up a policy. If you get a high reading on the sensor, call us in, let us verify with a more accurate sensor that that's an accurate reading. Trying to mitigate the concerns that might arise from that. It could be a good policy. It could help actually advance that sense of security for teachers as they have that ready access to that information. So I can see kind of arguments both ways. If you properly set up policies and communication protocols, I think that can be a good benefit for teaching staff to help increase their security level with spaces. There was another question on if your building is negative due to multiple fume hoods, so like a laboratory classroom building. Your building is drawing in outside air through walls, gaps, and leaks. Typically, if you've got a building that's negative, there is some design issue there. Buildings in general, even laboratory buildings with high exhaust rates, are going to be positively pressurized to the outside to prevent drawing in contaminants. So there should be, if your building is negative, there should be a tweak to the air handling system to increase outside air introduction to the space. to bring it back to a positive rate. You can have rooms in the building that are negative relative to other rooms, but the building overall should be positive, even if you've got laboratory ventilation and things like that. Will a copy of this presentation be posted? Yes, we will be sending out this presentation for your reference in the future. We also have a recording of this presentation that will be available, so you have all the commentary as well. Are we familiar with a system that uses bipolar ionization in conjunction with UV lights in the room, in light fixtures when the room is occupied? Yes, we have seen systems that for in-room air purification mount on the ceiling, and they have UV lights built into them, or ionization technologies, or both. They are somewhat expensive to install, but they are available out there. And since they are circulating, usually with occupants in the space, you get thermal patterns that rise out of the airstream. That's going to bring contaminated air from occupants up with those thermal plumes to that unit. They do have a very high effectiveness as far as clean air delivery rate. But again, cost is probably the main consideration for those units. So you've got to mount them to the ceiling, so you've got to have some additional support to actually support the weight of that unit there. And then the cost of the unit itself with those additional technologies is an important factor.
Hello, Sean. Can you hear me?
Yes, Ty.
So I just wanted to mention to the audience that, as you were showing the extra costs for increased ventilation and potentially for filtration and other things, that those numbers like 10,000 CFM, that's enough for 250 to 500 students. And so a potential increase in blower power, really is coming down to about 50 cents a student. And so if you look at it as, what that cost is per student, it really isn't significant and well worth it, as you mentioned, as far as the health. And then I had posted a webinar from last month by EPA with Washington, D.C. schools, which have done a lot of remediation. And there's a lot of good information there as well on what they've undertaken. And then maybe the most important thing out of their talk is that there's going to be about $150 billion or more for implementation in schools to improve the ventilation. And so having shovel-ready projects, getting in and finding out what you're lacking as far as difficulties moving airflow through a MERV 13, which really shouldn't be too difficult. That's telling me something else is a problem rather than the filter, because it's not a noticeable change to almost all blowers if there's not other things that need to be updated. But any case, there's a lot of money coming around, and as I mentioned in that webinar, this is a once in a generation type of opportunity for us to improve our schools. And then finally, the next webinar that CDAC will host, where we'll go more into some details, but then the workshops that are associated with these webinars, where we look forward to interacting in more direct interaction in groups to see how to actually do these analyses and address these strategies for improving your schools. Thank you.
So I do want to introduce a couple more people that have been added to the panel here. Todd Rusk is an engineer at the Smart Energy Design Assistance Center. You just heard from Ty Newell. He was a professor at the U of I and works now with air ventilation systems. Ty, you want to give a brief background on yourself?
Yeah, I'm old, and I'm old as dirt. Been working in this stuff for over 50 years, and so that's about all there is to me. But yes, I work in building sciences and renewable energy, and you can Google and find all sorts of odd stuff about me.
And then we also have an architect in our office. Robert Nemeth has also joined as well. So please, if you do have additional questions, please enter those into the Q&A window. We do have one that just came in. What are your thoughts on photohydroionization technology to treat your spaces? That's a technology that I am not yet familiar with. I would have to do some research into that technology. So I do not have a direct answer for you. Um, I'm not sure if anyone else on our panel has had experience with that type of system.
Sean, I think I just mentioned that, ASHRAE is moving as fast as they can as a lot of these different technologies are coming into play. And I'd say until ASHRAE has done research that then lets you properly design, how many watts per CFM is needed for a certain level of effectiveness of this technology or that, staying with the tried and true, which is MERV 13 filters, as you mentioned, and ultraviolet germicidal irradiation, if you'd like that next level of assurance and redundancy, and then fresh air. Just grab that stuff that Mother Nature has purified for us. Hopefully you're in a region where that can be, that's true outside, but those are the things that will keep our classrooms safe.
But I will follow up on that photohydroionization technology. We'll look into that and we'll see what's out there as far as resources and pass those along to you. So I would like to highlight, as Ty mentioned, we do have a second webinar in this series coming up on April 22nd. It'll be at this same time block, covering implementation and communication of building safety measures. So we're going to have this panel of specialists. Ty will be on that panel. We're going to be talking about ways to implement these, document that implementation, and communicate it out to the communities to make people feel safe with returning their students back to school. Scroll through the chat here and see if we missed any questions quickly. Okay, looks like we've covered all the questions in the chat. We will stay on a few more minutes. Again, I want to go back to this survey link. Please take the time, complete that survey. Again, it helps us verify for this program the effectiveness of these training materials and the impact it has on your decision making. And also helps us understand where you're at as far as your understanding and what additional materials we might need to cover in the future. So please do take the time to fill out that 5-minute survey and help us out with that understanding.
Sean, this
Yes.
is Linda Larson, and I'd like to add also that we have in the chat, we've posted a fact sheet that summarizes the main points from today's presentation. I'll repost it again, and feel free to download that, print it out for people in your school district, for the building managers and others. And we will be sending all participants a recording and presentation slides so you can refer to all of the material that we shared here.
Thank you, Linda. Seeing no further questions coming into the chat or the Q&A window, I would like to thank everyone for joining us today. We'll give you back about 15 minutes in your day. Again, we hope you can join us on April 22nd for our follow-up webinar. Again, going over implementation and communication. And if you do need some additional assistance, have specific questions for us, please feel free to reach out to us, cdec-info@illinois.edu, or call our 1-800 number. We'll be glad to go over any ideas you might have or any assistance you might need with your systems. We did have one more question come in before we wrap up here. Are there different levels of efficiencies for HEPA filters for in-room purifiers? So a HEPA filter itself has a specific filtration efficiency to qualify as a HEPA filter. The main thing to consider with those units is the clean air delivery rate, which is a documented component of those systems. And it's related to how much air can move through that fan system for filtration purposes. So when you're looking at HEPA filter systems, look at the documentation on what that clean air delivery rate is. And that's your key feature that you're looking for. And usually that clean air delivery rate is abbreviated as a CADR. So if you're looking through the materials for that, that's the acronym you'll be looking for. All right, seeing no further questions coming in, I want to thank everyone for joining us today, and I hope you have a wonderful day.